3.3 brings us to function notation. And function notation is something that's very useful as we get into more advanced math. But just remember, it's just a notation. We'll get all into that in this video. First, let's consider the scenario and write a function to represent. Christy wants to go to the fair. General admission is $12 and each ride costs $2. So the first thing we're going to do is we're going to put this information into a chart just so we have a good understanding of what's actually happening here. So I'm going to make my chart and I'm going to think of it in terms of rides and cost. So it costs $12 just to go to the fair. So even if Christy rides 0 rides, the cost is still $12. If she rides 1 ride, it's $12 plus $2, which is $14. If she rides 2 rides, that's still $12 plus 2 times 2 is 4, that's $16. So the cost is going up by $2 every time. 3 rides, $18. 4 rides, $20. 5 rides, $22. So this is what's happening in this function. This is a one-time admission fee of $12 and then $2 times every ride. So now let's think of this algebraically. And we're going to write this as a function using function notation. Now, function notation we normally see is f of x or g of x. Notice what I'm saying here. That's not f times x or g times x. That's read f of x or g of x. So what's happening here? All we're doing is giving a function a name. That's it. Well, we're going to call this the cost function. Remember our chart? Rides, cost. Let's call this the cost function. This is the cost of going to the fair in terms of rides. So C of R. C of R is short for cost in terms of rides. So what did we say? It cost $12 just to go to the fair, and then it cost $2 for every ride. So this is the cost function, C of R, in terms of R. 2 times each ride plus $12. So that's how we can write a function. So let's think about this. What is the independent variable? What depends on what? Does cost depend on rides or ride depend on cost? Well, if this is our function, if it's C of R, the independent variable is the number of rides. As the number of rides increases, the cost increases. So what's the independent variable? Rides, which means that cost is dependent upon rides. Now here's a new question for us to consider. What is a reasonable domain interval? Well, first of all, is it really going to be an interval? Let's think about this. Is this going to be a discrete function or a continuous function? Well, if it's going to be by the ride, I do believe we shouldn't ask for an interval because this is a discrete function. So a reasonable domain would not be an interval but a roster. So our domain here, and look at what we put in our chart. Maybe Christy goes to the fair and she doesn't ride anything. She rides 0 rides. So I would have to say a reasonable domain would start at 0 and then include the whole numbers 1, 2, 3, 4, and so on. I mean, maybe she stays there for 2 weeks and does nothing but ride. But she either rides the ride or she doesn't. There are no half rides, there are no third rides. So this is a discrete function. So let's sum it up here. Function notation simply gives a name to a set of what? To a set of directions telling the user what to do with the input values. So look at the function that we just created. The function we just created said double R and then add 12. Those were the directions given in the function. So function notation simply gives a name to a set of directions telling the user what to do with the input values. So here's a new function. This is the H function. Once again, let me remind you, this does not mean H times X. This is read H of X. That's it. So what does the H function tell us to do? It tells us to square the input, add that to double the input, and then add 3. Remember, these are the directions telling us what to do with an input value. So let's evaluate one. Let's put in X equals 10. So when you see H of 10, it's asking this question. What is the value of the H function when X is 10? H of 10 means this question. So let's evaluate the function when X equals 10. So everywhere I see an X, I'm plugging in 10. Notice my use of parentheses here. Parentheses are very helpful. So we're going to follow order of operations. And remember, order of operations starts with grouping symbols, followed by exponents, followed by multiply or divide, followed by subtract or add, all in order from left to right. So, if that's the case, we will deal with the exponent first. 10 squared is 100. Then, working left to right, next multiplication, 100 plus 20 plus 3, and of course 100 plus 20 plus 3 is 123. So, what is the value of the H function when X is 10? The evaluation is 123. Evaluating a function. One last problem to consider. Let's read it. Write a function to represent the scenario. So here's our scenario. A personal trainer charges $60 for an initial session and then $45 for every session thereafter. Write a cost function to represent the total amount you would spend after S number of sessions. So we're trying to write a cost function. Now before we do that, let's identify what's independent, what's dependent. Let's think about what's a reasonable domain. Is this continuous? Is this discrete? So maybe we answer continuous or discrete first. If you contract a personal trainer to help you out at the gym, are they possibly going to sell you a fraction of a session? No, probably not. And it even says the initial session is $60. So this is not a continuous set of data. This is definitely a discrete function. Next, what's a reasonable domain? Well, let's first think about what's independent versus dependent. So if we are going to write a cost function, that must mean that the cost is dependent upon the number of sessions. So what's independent? The number of sessions. What's dependent is the cost. And remember, we're trying to write a cost function. So a reasonable domain, since it is discrete, means that our domain once again will be in a roster notation. Maybe we don't ever go. That means $0. Maybe we only go once or twice or 3 times, but our reasonable domain is going to start with 0. So now let's think about all of that and let's try to write our cost function. So once again, a personal trainer charges $60 for an initial session. So you get to see the trainer one time for $60. But then it's $45 for every session thereafter. So that means our cost function, which is cost in terms of number of sessions, so C of S is going to be, let's see, $60 plus $45 for every session thereafter. So 45 times S, well, think about it. The number of sessions has to include the one we're paying 60 for. So when we put in our variable here, if it's $45 for every session thereafter, we have to say the number of sessions minus 1, because the first session is $60. So now, let's think about this, and I'm going to change my answer back here. Because what is my reasonable domain? Can my reasonable domain start with 0? I don't believe it can, because it says a personal trainer charges $60 for the first session, but then $45 for every one thereafter. So can 0 be in the reasonable domain? No, because we're saying that we went at least one time. So here's our cost function. C of S equals 45 times S minus 1 plus 60. Let's be reminded real quick that S minus 1 represents the number of sessions after the first one. So here's our cost function. C of S, remember C of S does not mean C times S. It's just read C of S to represent the cost function. Then, what is our function telling us to do? Take the number of sessions and take away 1, multiply that by 45, and then add 60. Because function notation is nothing more than a set of instructions telling us what we're going to do to the variable. So if you went to the trainer 5 times, if you had 5 sessions, what would the cost be? Well, let's evaluate the function and find out. C of 5. C of 5 means go to the cost function and everywhere you see S, plug in 5. 45 times 5 minus 1, because remember, the first session was 60 and every session thereafter is only 45. So follow order of operations, do what's inside the grouping symbols first. 5 minus 1 is 4. And 45 times 4 is the same as 90 times 2, which is 180. 180 plus 60 is $240. So if you found a personal trainer who charges $60 for the first session and then $45 for each subsequent session, if you went 5 times total, you would pay $240. And that is function notation.